All right, so from sine and cosine, we're going to move on to tangent and then cotangent. Now, the process is very similar to how we do it. The differences are very small, okay? So we're going to have to rely greatly on what we learned before. That's why I went into so much trouble stressing all the stuff from before. All right. So let's start with tangent. In the very beginning, we defined tangent as sine divided by cosine. All right. Now, in math, every time you've got a rational function or a fraction where you have a variable in the denominator, you automatically have to watch out for, okay, the denominator cannot equal 0. So I can't put values into the function that make the denominator 0. Now, since tangent is sine x over cosine x, all those times where cosine of x equals 0 are problem points for the tangent. Okay, so let's remind ourselves what a cosine function looks like. This is a cosine function. Over the period of, over the course of its period, it crosses the x-axis twice. And we know every time something crosses the x-axis, we call those zeros. Okay, so every time the cosine crosses the x-axis, we say the cosine of x is 0. And those are where the tangent is undefined. Okay, so to reiterate, tangent of x is undefined at all points where cosine of x is equal to 0. At these points, the graph of tangent of x has vertical asymptotes. It doesn't matter. It doesn't matter. Okay, so let's think about where cosine of x is 0. If we look at the unit circle, okay, when the angle is 0 degrees, what's the cosine of it? This is the point 1, 0, so cosine of x is 1. At pi over 2, that's the point 0, 1, what's the cosine? 0. So there the cosine is 0. At the point at 180 degrees, it's negative 1, 0. What's the cosine? Negative 1. Here at 3 pi over 2, it's 0, negative 1. What's the cosine? 0. So there are 2 points over the course of 2 pi where the cosine is 0. It's at pi over 2 and at 3 pi over 2. Now, if we were to continue and go back up here, it would be 5 pi over 2. Down here, it would be 7 pi over 2. Then back up here, 9 pi over 2, 11 pi over 2, 13 pi over 2, 15 pi over 2. So basically, at all of the pi over 2's, you have cosine is 0 and you have asymptotes. Also the negatives. Negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, negative 7 pi over 2. So you see that it repeats very regularly. Okay? Now, here's a question for you. How much of an angle is there, okay, from pi over 2 to 3 pi over 2? It's a pi, okay? From 1 pi over 2 to 1.5 pi over 2, it's a distance of pi, okay? That means every time from here you go a distance of pi, asymptote, pi, asymptote, pi, asymptote, pi, asymptote. That means if the sine and cosine, when we said the sine and cosine repeat every time you go over 2 pi, but the tangent repeats every time you go over 1 pi. So if the period for the sine and cosine was 2 pi, For the tangent, it's going to be 1 pi. All right? That is the important part. So the period is going to be 1 pi for the tangent. Now, specifically, why do we care about that? Okay, let's write that here. The period of the function is pi. Why do we care about that? Because remember, for the sine and cosine, to find the period, we're doing 2 pi over b. Guess what we're going to do now? Just pi over b. Okay? Now, so that's one difference. Another difference is this. Sine and cosine started at 0 degrees and went to 2 pi, right? Okay, not so for the tangent. The tangent is a little bit of a rebel. Okay? The tangent, you can see here, starts at negative pi over 2 and goes to pi over 2. So rather than setting up our inequalities from 0 to 2 pi, we're going to go from negative pi over 2 to pi over 2. Always for the tangent. Okay? It's like, you know, it's got middle child syndrome. It's different. It's rebellious. All right? So it goes from negative pi over 2 to pi over 2. So the initial cycle starts at negative pi over 2 and ends at pi over 2. You could say it has a little bit of character, the tangent, right? It's like the one in the family that's got a little bit of character. Okay? All right. So why do we care about this? Like I said, until now, I programmed you to set up your inequalities to go from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. For the tangent, remember that's the rebel, we're going to go from negative pi over 2 to pi over 2. So to graph a tangent function, we're going to solve the inequality negative pi over 2 to pi over 2. By the way, when we do this, we also automatically solve for the asymptotes. Okay, those points give us the asymptote, the beginning and the end. So we solve the inequality like this, algebra. Then we graph the asymptotes. We find the midpoint. We've been doing that, right? Add, divide by 2, add, divide by 2. Plot the points to the left and right of the center according to the value of A, okay? We can make it more concrete with an example right now. Yes? That's where for the default, that's where it is. But if you have like tangent of 2x, tangent of 1 over 2x, then things change. All right? Okay, so here it says to locate the vertical asymptotes and sketch the graph. Okay? Immediately, we're going to start off with our inequality, but now we're going to go from negative pi over 2 to pi over 2. Now, one other thing, okay, like a little mathematical notation. You know how before it was less than or equal to, less than or equal to? Can't do that for this. It's just less than because at the vertical asymptotes, it can't be equal to those points. Okay? Yeah. That's wrong. Huh? It might have been my mistake. It was probably my mistake. It was my mistake. My fault. I made the calculus packets, pre-calculus packets a long time ago, and then this one I copied and pasted from there. So, okay. I don't need extra credit, Maya. Okay. So here, in here, we put this, just like before. So this is like the simplest case scenario. We just have an x in there, and oh my gosh, look, it's already solved for us. We're good to go. So now my asymptotes are at negative pi over 2 and pi over 2. Okay? This one is already, you know, it's the simplest case. This is the x-axis. Negative pi, I'll answer that question in a minute. So negative pi over 2, same situation. You put the first point and then you go 4 over. 1, 2, 3, 4. Okay? Now, what is the midpoint between negative pi over 2 and positive pi over 2? Right, which gives us 0. Divide by 2, we get 0. So remember, if it's negative something and positive the same thing, the middle is 0. Now, let's do the one on the right-hand side first. What's halfway from 0 to half pi? Quarter pi. Okay? If you're halfway through eating half of a pie, you've had a quarter of a pie. And then it's going to be symmetric on this side, negative pi over 4. Always think of it in concrete terms. I have a full pie. I want to eat half of it. It's half pi over 2. I have half a pie. I want to eat half of it. That's the quarter of the full pie. Okay? Now, at negative pi over 2 and pi over 2, we're going to have our asymptotes. So the reason why we do it this way is because those endpoints are always going to be our asymptotes. Now, the rest of it is simple. Here's how it's simple. For tangent, the center point is always going to be 0. Okay? Now, take a look at tangent. We're going to look at this one branch of it. If you look at it, it's positive to the right, negative to the left. Okay? Positive means it's above the axis to the right, below the axis to the left. Tangent is going to look like that always, unless there is a negative at the very front. So, what do? You see the last step here? It says plot points to the left and right according to the value of A. A is the number that is at the very front. So here, my A is 1. If it's positive, I go up on the right, down on the left. If it's a 1, I go up 1 on the right, I go down 1 on the left. That's if it's a positive, and if it's a positive 1. Once you do the asymptotes, the points are always going to be that simple. There is minimal thinking involved. The middle is always at the center, vertically, and then you go up 1, down 1, unless you have a different value of A. Okay? And we'll do some more of those right now. So, here's what's important here. This is how the tangent is going to look. There are a couple of important things here. Asymptotes, mathematically, are the following. Asymptotes are lines that the graph comes exceedingly close to but never touches. Those of you who have had me, before this, it's the same definition every single time because that's what it is. It's a line that the graph comes exceedingly close to but never touches. So your graph has to match that. It has to come very, very close to the asymptote, like following it upwards, but never touching it. And here, following it downwards, but never touching it. It's almost like it's a totally vertical line here, which eventually it will be. Here, based on experience, in the middle, I get all sorts of, waves. Okay, I get that for a tangent all the time. That is not a tangent graph. By definition, that is something else. What I want you guys to look at is this. You can split tangent into two. The first part here, okay, think of it as like a trophy cup, right side up, right? It's half of a trophy cup. And then here, it's an upside down trophy cup. So that's it. It's just one upwards and one downward. There are no other curves anywhere along the line. Okay, there are no other bumps along the line. Okay? All right. So I spent all this time on this first one. Now the other ones we're just going to follow and do a little bit more quickly. Yes? You don't have to put arrows. All right. So we're going to graph this. And it says, notice the change in the value of A. In the beginning, though, we don't really care about A. What we're going to do is set up our inequality, negative pi over 2, pi over 2, and in the middle, we're going to put in x. Okay? It's already solved for us. we have our x-axis. Okay, so we go from negative pi over 2, 4 spaces, to pi over 2. Those are where my asymptotes are. All right, let's label the other points. I have 0 in the middle, negative pi over 4, and pi over 4, just like before. Now, in the center, it's always 0. Okay. Now let's take a look at our value of a. This is my a. It's positive, that means same as before. It's going to go up on the right, down on the left. But because there is a value of 3, it's going to go 3 units up and 3 units down. And what that does is it doesn't add extra curves to it, just the opposite. It makes it a little bit flatter, right? Almost straight, yeah. This 3. If that 3 is positive, it means it's still up on the right, down on the left. Okay? All right. So now, let's do one with a negative. It's going to be negative pi over 2 to x to pi over 2. So same deal. Our asymptotes are at negative pi over 2 and pi over 2. We label. Okay, at the center it's always 0. Now, there is a negative 2 in front. The negative means I need to go to the down on the right. 1, 2 here, 1, 2, and then up 2 here. So a negative means there is a horizontal reflection. There's a reflection on the x-axis. Because at the very front here, there is a negative 2. There is a minus in front of the equation. Okay? So again, don't put in too many extra curves. Yeah, at the asymptote. Okay? All right, so now, so far, the 3 that we did, it was, the same location for the asymptotes, negative and positive pi over 2. Okay, when does that change? Well, here we go. So here, we're going to go from negative pi over 2 to pi over 2. This time, notice, after the tangent, it's not just an x, it's a 3x. So I put a 3x there. Now, if it's 3 times x, like Max said, I need to divide by 3. Divide by 3 is the same as multiplying by 1 over 3. Okay? Or you multiply to the denominator. So, negative pi over 6, x, pi over 6. Okay, now, you see how here on the top it asks for the asymptotes? The asymptotes are going to be the first and last points of this inequality. So we say x is negative pi over 6, x is positive pi over 6. Are they always going to be? No. No. If there is a phase shift, like if it was 3x plus 2 pi or 3x plus pi over 2, like this one, let's say, then it'll be different. Yeah. I mean, it's more purposeful, but yeah. So here is what's important. Must have x equals there. So don't just say the asymptote is negative pi over 6, because it's not. It's x equals negative pi over 6. And yes, then we can do that. All right. So when it's a matter of choice, I give you guys the choice. But if it's a matter of, correct or incorrect math, then it's less of a choice. All right, so we're going to go from negative pi over 6 to pi over 6. The middle is 0. These are where our asymptotes are at the ends. What's the midpoint between pi over 6 and 0? Pi over 12, correct. We divide by 2. Negative pi over 12, pi over 12. Okay, now, center is 0. Where do I go on the right? 1 and 1 on the bottom here. Awesome. It's not complicated. You just have to be careful. Okay? If you're multitasking, you're going to make mistakes. I make mistakes when I'm multitasking. All right? Okay. So let's do this tangent. We're going to go from negative pi over 2 to pi over 2. What do I put in the middle? And I multiply by 3, so I get, right. Okay, so those are where my asymptotes are. All right, now let me show you a little bit of notation. Here, when I ask you for the asymptotes, if it's the same number, just plus or minus, rather than saying x equals negative 3 pi over 2, x equals positive 3 pi over 2, plus minus. Okay? All right, asymptotes. Middle is 0. Middle point is 0. What's the midpoint? Okay, so we're gonna, it's 3 pi over 2, and then we're gonna multiply by a half, so it's negative 3 pi over 4. 3 pi over 4. And we're gonna go same orientation. Okay. So it's the distance between 0 and 3 pi over 2. I add them, I get 3 pi over 2 divided by 2. So 3 pi over 2 divided by 2 is like times 1 over 2, right? So that's 3 pi over 4. Okay, now this is more interesting. It's a negative, and it's x plus pi over 2. So we're going to go from negative pi over 2 to pi over 2. And inside, we're going to put x plus pi over 2. So what do I do now? Subtract pi over 2. Okay, so look, in this case, I have negative pi over 2 minus pi over 2. So it's negative pi. It's negative half pi minus another half pi. So if you owe somebody $50, you're in the hole. You're in the negative for $50. And now you owe them another $50. How much total do you owe them? $1. So if you owe somebody half a pi, and then you end up owing them another half a pi, now you got to give them a full pi. Okay? So it's negative pi x to 0. Right. So now we're going in the opposite direction. So my asymptotes are x equals negative pi and x equals 0. Okay. We go here. Let me make it straight. Not necessarily. If it was symmetric, if it was going from like negative to positive of the same number, then yes. All right. Right. They're not the same, so we got to do a little bit more work. Correct. So now, halfway between 0 and minus pi is minus pi over 2. Okay, the one here between the 0 and the pi over 2. What's halfway from 0 to half pi? It's a quarter pi, right? Negative pi over 4. And then 3/4. What's halfway between half a pi and a full pi? 3/4 of a pi. Okay, now, once you do this, the rest is the same. The center is always 0. Now, pi over 4. Negative pi over. Now, to the right, am I going to go up 1 or down 1? Down 1 because of the negative. And then that means I got to go up 1 here. Okay? Now, one last thing is the cotangent. Cotangent is defined as cosine over sine. Therefore, it's undefined wherever sine of x is equal to 0. At these points, oops, this should say cotangent. At these points, cotangent of x has vertical asymptotes. Now, the period again is pi. Okay, so that's where tangent and cotangent are the same. But now, let's throw another wrench into the mix. The cotangent is less of a rebel than the tangent. So just like its brothers and sisters, it starts at 0, but ends at pi. Okay? Only one that starts at negative pi over 2 is the tangent. I'm telling you, that's the rebel of the family. So to summarize, sine x, cosine x always go from 0 to 2 pi. Tangent goes from negative pi over 2 to pi over 2. Cotangent goes from 0 to pi. Okay? Once you remember those, like 3/4 of your work is done. So same deal. We have to solve this inequality now. Graph the asymptotes, find the midpoint, plot the points according to the value of A. Okay? We're going to throw another wrench into the mix now. I'm just going to do this one and then we're going to stop. Huh? Yeah. So now we're going to graph cotangent of x plus pi over 2. What are the boundaries? 0 to pi. Inside, I'm going to put x plus pi over 2 for cotangent, correct. Now I'm going to subtract pi over 2 from everywhere. All right, 0 minus pi over 2, negative pi over 2. X, 1 pi minus half a pi is half a pi. Yeah. So, negative pi over 2 to pi over 2. Look, it's symmetric. That makes my life easier because what's exactly in the middle? 0. And then it's pi over 4 and negative pi over 4. At the center is 0. Now, you want another wrench into the mix? Well, here it is. It's the opposite of tangent. Rather than going up,
you go down.
On the right, I'm going to go down on the right. Okay?
So if it's negative, you go up.
Yes, correct. For tangent and cotangent, they're reversed. Tangent would have gone up on the right. Cotangent goes down on the right. Okay? They're like, okay, now, for tomorrow, your homework is the following. 4.5 part 1, 1 through 8 all, okay? Those are all of the tangent and cotangent graphs. Okay, here it is. Do you guys want credit for this homework?
Yes.
You have to do it on graph paper.
Okay.
Do you still want credit on the homework? You have to, I know, this is only on tangent and cotangent. The graph? None. None. You have to draw your x-axis with a what? A ruler. Okay?
Just draw a straight